Okay, welcome everybody. Thanks for being here. My name is Mariano Nunez Di Croce. I'm from Argentina. So when we get to the Q&A section, no jokes about the World Cup, and nothing never happened there for us, okay? So I'm here today to talk about SAP Backdoors. We're going to be spending the next hour talking about how a malicious intruder, a fraudster, could install a backdoor in an SAP system, perform really a fraud attack with that kind of compromise. First of all, I would like to know how many of you know that in your company you are running SAP? If you could raise your hands. Well, okay, pretty much all of you. Probably otherwise you will be in another talk. Okay, let's begin with this. So I work for a company in Argentina. It's called Onapsis. We are focused on the security of ERPs and business-critical applications. By business-critical applications, we are talking about SAP systems, but we are also going to be focused on Siebel, Oracle Business Suite, and JD Edwards. Okay. Our core business areas is the development of ERP security software. Probably you have not heard about X1 because we are kind of releasing it next week. But you can check our website for see some information. X1 is a ERP security vulnerability assessment and penetration testing suite. Who has ever heard about Bizploit? Hands up. Okay. Sapito, maybe? Okay. Bizploit is an open source project that is an ERP pen test framework. So you can download it from free from our website and do some kind of assessments over your ERP platforms. We also do security consulting services specialized in SAP and this kind of business-critical applications, and trainings as the one we were holding these last 2 days here on Blackhat. As I mentioned, I am Mariano from Argentina. I'm working as the Director of Research and Development at Onapsis currently. I was originally devoted to pen test and vulnerability research, so I come from that kind of technical field. I have discovered some vulnerabilities in critical software and spoken in some conferences around the world. Okay. So this is what we are going to go through in this presentation. We're going to make a quick introduction to SAP systems. Then we're going to see how it's possible for someone to create a ghost user in the SAP user master. We're going to see how backdoors can affect business modules and how it's possible to backdoor the authentication procedure of an SAP system. And then I'm going to present you a free tool that's called Onapsis Integrity Analyzer that's going to be helping you to prevent this kind or detect this kind of threats. So, what is SAP? SAP is, as you have many hands up, is actually the largest provider of business solutions in the world. So SAP has more than 140,000 implementations around the globe, actually more than 90,000 customers. Okay? More than 90,000 companies in the world are currently using SAP systems. Which kind of company? Usually not very small companies. SAP is used by pretty much every Fortune 500 worldwide company, governmental entities, defense facilities, and they use it not just to make a simple process or something that is not critical. They're running their everyday business process through that systems. Okay? So business process like invoicing, managing sales, managing financial planning, managing human resources, payrolls. So pretty much everything that happens in a company where SAP is deployed goes through that systems. Okay? So that's really critical information. So I guess that if you're in Blackhat, you pretty much all of you know what is a backdoor, but this is like just for refreshing. The idea of a backdoor could be defined of some special methods or techniques or tools that are implemented in an information system, usually after an unauthorized compromise, okay, something that is done after a compromise, with the purpose of securing future access to the system and trying to remain undetected. Okay? So that's what we are pretty much going to show today. So what's special about SAP Backdoors? We have been talking about backdoors for several years, pretty much since information systems exist. But the thing is that there was really little, or actually pretty much known public information on how this threat affects SAP systems. Okay, so And you, most than no one, know that the fact that the information is not public, it doesn't mean that it's not being currently exploited, okay? Because you all know that there are a lot of people working in dark places, trying to do malicious activities. So, as I told you before, SAP is like a juicy target for malicious attackers. I'm also trying to make a point with what I think is the biggest misconception in the SAP security world. SAP security is usually considered a synonym of segregation of duties. Okay? When you talk about SAP security to one of your colleagues at your company, he's going to probably tell you that, yes, we do roll out some profiles, we manage user authorizations. What we're going to see, and actually I made some presentations before, and in the trainings that we do, we try to show that SAP security is much more than segregation of duties. The thing is that still many standards and regulations still don't get it. Most auditing companies still don't get it, and unfortunately some customers are still not getting it. Okay. So why are we talking about SAP security? I made my first presentation on Blackhat in 2007 in Blackhat Europe. I am still here talking about this, so why I keep bothering with you with this stuff. What's important to know is that SAP vulnerabilities are pretty much in a rise. This is a graph showing SAP security nodes, okay, that can be pretty much similar to what is Microsoft security bulletins. So you can see that SAP security team was probably pretty much relaxed in 2001. There's not so much work to do for them. And, well, it was growing slowly until, I hope that I have nothing to do with this because I did a presentation in 2007. But we see a really deep or a high increase on the number of security nodes that SAP releasing every year. So we were talking about less than 50, I think it's 20-something in 2007, and we are probably going to end this year with more than 300 security nodes, okay, per year. So it's something that's starting really to grow, and of course, if there is a security node there, it is fixing a security vulnerability, okay? So the security vulnerabilities that are currently existing for SAP software are rapidly growing, and so is the involved risks. Going to a technical level and explaining why segregation of duties is not enough, you should know that by default, just by knowing the IP address of an SAP system, a remote anonymous attacker can just execute operating system commands on any SAP system up to date that is left by default. And it's also possible due to some misconfigurations on SAP and Oracle installations. It's also possible to take, for an attacker to take complete control of an SAP Oracle database in pretty much any implementation that is currently running with default security settings. And I'm talking about no authentication, no kind of privilege, just anonymous and just getting network connectivity with the SAP server. So I think also this makes a point. We do security pen testing and we do vulnerability assessment to our customers. This is a particular example that during an assessment, we were testing a really tight SAP system, was really SOT compliant from that point of view. You have to believe me that this costs, and you may know it, that it costs really a lot of money to have this right, and it's not really common. But this system was possible to be compromised in a matter of seconds to exploitation of a technical vulnerability in the system. Okay? So with that kind of privilege, an attacker could have installed a backdoor for sure. So what's actually, okay, we're talking about technical issues. What's the risk? Okay, what's the problem with these issues? We technical people used to say, okay, this is meaning problems for the confidentiality of your information, for the availability of your information, and for the integrity of information. But the thing is that if you're in your company and you tell this to your CFO or to your CEO, he's probably going to look like, yeah, I have a lot of tasks to go away. So I think it's a matter of communications, just to try to speak their language, okay, so we can say pretty much the same things with a different word. So if we are talking about confidentiality, we are talking about espionage attacks. We're talking about availability. We're talking about sabotage attacks. And integrity, we're talking about fraud. Okay? So maybe the CFO will now pay a little more attention to you. And it's actually not about scaring no one. The idea is just we have to be able to speak their language, okay? Because they are really pretty much the decision makers in the companies. Yeah, unfortunately. Okay. So I told you before that for someone, well, you know that for someone to install a backdoor in a system, he has already compromised it. Okay, so all the things that we're going to be looking at today is what an attacker that has already compromised an SAP system, which techniques he can use to backdoor it. So in an SAP system, the threat model will be composed of these components. You have the base operating system, database layer, and then you have the SAP system running on top of that, where you have the technological application layer and the SAP business layer. Okay? So the attacker could exploit vulnerabilities in any of these components. Okay? So he may exploit an unpatched Windows vulnerability. Many SAP systems run unpatched. He may go through the database layer, exploiting some of this weak SAP Oracle architecture, or a database, an Oracle default password, or a SQL Server 2000 vulnerability. He might have been able to discover a weak profile. He's a user of the system, and he has a wide profile, so he can do more things that he should, and then he's able to get control of the system. Or he can directly attack the SAP technological layer. Okay? That is pretty much what we are working on. What you should know is that no matter what, I mean, any of these layers that the attacker gets to compromise, he will be able to compromise the whole platform. Okay? So I did this presentation on Blackhat in Europe, in Barcelona, a couple of months ago, and it was getting some press attention. And there were some mistakes because people thought that it was a database vulnerability. So this is what we're seeing is not a database vulnerability. The thing is that SAP has a lot of internal trust relationships between the different layers. So if an attacker gets to be OS administrator, he will be the same to get a DBA of the database, and he can get SAPOL of the SAP system. SAPOL is like the most powerful profile. And it's like both ways. Okay? So he can, just getting one weak link, he can do anything that we're going to be showing today. You can check some presentations, old presentations for that. So while I was making this presentation, I was thinking that, okay, let's try to make it a bit more, or less boring. And we're going to be using a froster. Okay, so I want you to meet the froster that is going to make these attacks. Actually, I was trying to think who could I use to be the froster. So this first one came to my mind. You probably know him, Al Capone. But it was not good. It was a bit outdated. So I keep on thinking, and I thought about our friend Bernie Madoff. You probably know him. He was arrested a couple of years ago. But actually, it was really naive still for me. I mean, he did one of the biggest fraud in history, but he was still a bit naive. So then I realized that I have overlooked the biggest fraudsters in history. That was Carlos Saúl Menem, former Argentinian president. That it's really, really the best criminal I've ever get to know of. Maybe you will know him because he's from Argentina. Maybe you know his brother. So you see that in Argentina we're kind of ruled by monkeys. So they're pretty much the same. So okay, Menem is going to be with us in all these slides and helping and serving as the froster. Okay. So let's talk about the first practical issue, and it's the possibility of someone installing a ghost user in the SAP system. And it's going not to be as happy as that one. So before talking about this, if you're not used to the SAP world, you should get some basic concepts. The first thing you should know is that you as a user, connect to your SAP system through a special program that is called SAP GUI. Okay? It's the SAP client to connect to the server. In order to connect, you have to specify access credentials. So you have to specify which client is. It's a number that is a logical independent unit in the system. But for this, you can see it as just a number that you have to specify. Then you have to specify your username and your password. Okay? So then when you log in, the system will check if your password is the same one as in the user master table, and if it's OK, you are granted access. So then you just start using transactions and making business processes. The problem is that there is something called downwards compatibility in SAP systems, because you may have a complex landscape composed of really new systems, but you can have some legacy SAP versions. So we're going to see what it means from the security point of view. A long history, SAP has implemented several password hashing mechanisms. Okay? So they started with a really weak, 8 characters long, case-insensitive MD5 password hashing mechanism. And now the most modern versions are running a 40-character long, case-sensitive, and based on SHA-1. Okay? So it's much stronger. The problem is that when a weak system, when an old system that doesn't support the newer hashing mechanisms wants to integrate, wants to connect with a new system, integration will fail because he doesn't understand new hashing mechanisms. So integration fails, you cannot connect your systems, and your business fails. So what SAP did, the workaround to be able to keep on the system the business running, is that the user master, yes, the record for each user in the database will contain the downwards compatible hashes as well as the strong one. Okay? So this means that there is more than one password hash per user. This by itself introduces some different attacks that you can check it in. You can download it from free from our website. It's a publication that I did about this, but that's a different story. So I told you that each user is going to be containing 2 password hashes. So when you type in your password in the login screen, which password hash the system use for comparison? This is controlled through a profile parameter, yes, a configuration of the SAP instance called login password downwards compatibility. So this parameter can have one of these 3 values. Value number 0, that means that there is no downwards compatibility, so no weak hashes are generated. This is actually a secure setting that you should use if you are not integrating with all systems. The default value, number 1, that means that downward compatibility is enabled. And weak hashes are generated but are not evaluated. Okay, so they're just only using some internal interfaces. Value number 2 is that if the password you type to log into a system, when you type in your password, it will check it against the new and the strong hash. If it fails, it will check it against the old hash. Okay? This is used to detect compatibility problems, but the system will log this and deny the access. We'll just let you know that there is a compatibility problem. But just reading at the documentation, I realized that there was 2 other values that this parameter could have, and are these ones. Value number 3 and value number 4. Value number 3 is pretty much the same as 2, so it means that your password is checked against the strong one, and if it fails, it's checked against the old one. But with this slight difference that if the second check matches, if the second check works, the logon is granted as successful. And this is registered in the system log. And don't ask me why 4 is there, but because it's the same as 3, but no system log entry is written at all. Okay? So now we're going to see how this ties together. To make things a bit worse from a security point of view in practice, is that in order to change parameter values in SAP, you need to, there are 2 types. There are static and dynamics. Static, you need to restart the server. Dynamics, they just take place. This parameter is dynamic, so it means that you can change it without restarting the server. Okay? So let's see how this gets into a problem. So I'm going to, this is SAP GUI, the SAP GUI interface. So I'm going to be like Menem now. I'm going to log into the system with the SAP star user. Let me make it bigger. the substar user, that is like a super user, so I have already control of the system, and I log in with the password that I know of the system. So what the attacker will do is to go to the SC16 transaction that allows him to access database table. So the user master table, the password hashes are stored in this table, USR02. So I'm going to show you that here you see that you have all the users in this client, and here you have the password hash. Okay? So we're going to go into this record, the substar record. And you see that here is the password hash, but if you go down, there is the other password hash. Okay? So this is the strong hash, the SHA-1 hash, and this is the old weak hash. So what we're going to take advantage here as an attacker is to enter, if you see, I cannot type here. I cannot modify this value. Okay? So what the attacker could do is to enter a special mode in SAP system that is called debug mode. It's done executing a /h. So it says here in the bottom says debug is switching on. And he will just press enter on a field. And this kind of attack is, not the entering debugging mode and modifying database table through the SAP system has been known for a long time. I could also be doing this directly through the database, but I'm trying to show you that this can be done through the SAP system itself. So here you see that this is ABAP code, the ABAP code that processes that information. So here you see that there's a variable called name code. So let's see what it has. Code is equal to show. What we can say is that, okay, no, you are not show, you are edit. Okay, so I think that now, no, sorry. I have to, I just changed the variable to edit, and I let the execution to continue. So now you can see that I can modify this field. So I'm modifying the old hash of the user. And I'm going to, I have a generated hash for a password ghost1. Okay, so I'm going to copy this and put it here. So I save this, and here it says that the database record was successfully created. So the attacker goes back, and the next thing, if you remember what we are doing, the next thing, that he has to do is to modify this parameter, okay? And he will modify it to value 4, that is the most stealth mode. So he goes to the transaction to modify profile parameters, login, password. And here you see that it's in value number 1, so he will change it for number 4. He save the changes. It will say that it's dynamic, so you lose it when you restart the system. Okay, let's give it a couple of seconds. Okay, so yeah, it's going to be dynamic. So the parameter is changed. So this is the end of the attack. So let's see what happens here. Now the attacker leaves the system. So the SAP administrator connects to his system, and he logs in with his own password. You're not going to be able to see the password, but you'll see the length difference. So he entered with, you see that there are things like 8 characters or something. So he can log into the system. But as he can log in into the system, this will be the legitimate administrator, the attacker can log in with the same user with password ghost1. Okay? So you can bet that the administrator will never notice that his weak hash version is different to his strong hash version and stuff. So basically what attacker is doing with this kind of attack is he has like a permanent backdoor for any user, so he can log in with that username, he can log in using that username with a different password. Okay? That's the first possibility and the first attack vector. So protection and countermeasures against this. There shouldn't be no reason at all why you have this value set to 3 or to 4. Okay? It is supposed to be just for test purposes. I don't know why 4 is there, but 3 is for test purposes. So you should keep monitoring that value and make sure that it doesn't never get to that, that parameter never gets that value. And you have all, just an additional measure, you should protect that no one can modify the user master table. Okay? But if he's already administrator, he can do anything he wants. And there is also a note, a reference to a SAP note that you may want to take a look at. So that will be the first attack vector. Now we're going to go into something more dangerous, that is the possibility of backdooring an SAP business model. Going to talk about a little of basic SAP concepts. The idea is that you as end user, once you log into the system, you are interacting with transactions. So every time that you run a transaction, you are actually running an ABAP program. Okay? ABAP is a proprietary SAP development language. So almost everything is developed in ABAP. So ABAP programs can be divided in standard programs that are the ones that are shipped by SAP, and as soon as you install the system, all those programs there have been developed by SAP. And you have custom programs that are programs developed in-house in company to customize the system and adapt it to your needs. So this kind of program, you can recognize them easily because they start with a Z or with a Y. So the reality is that standards programs can be modified, and it's done sometimes, but it's strongly discouraged. Because if you do that, you pretty much lose SAP support, and SAP doesn't guarantee that a new upgrade won't override your standard program. So it makes sense. So you should not do that. Even though if you want to do that, a special procedure called SSCR will step in and will ask you for a special key. So if you want to modify a program, there will be a pop-up that says, okay, you are trying to modify this program ID, send this serial number to SAP, and they provide you a key that you type in, and then you are allowed to modify it. So this way, SAP keeps track of what you modify, and then if you have any support issue, they will tell you it's your problem now. So the idea is that ABAP programs are actually, as pretty much what's in SAP systems, is stored in the system database. So there are two tables. The first one, repo SRC, that contains the compressed source code of each ABAP program, either standard or custom programs. And the second one is repo load, that contains the ABAP is also like precompiled, so you find something similar to bytecode there. So in a typical SAP landscape, you'll find at least three systems: development system, quality assurance systems, and proactive systems. Development and changes can only be done in the development system. Okay? That's between quotes for now. The idea is that you will develop something in the development system, transport it to the quality assurance system, there is going to be tested there, and then it's transported to the production system. So the production system is configured to block any attempt to modify or to create a new program directly into that system. Every change that is to be done in the production system must have followed all these steps and this transport workflow. So through this procedure, it's expected that the quality and availability of the SAP production system is maximized. Okay? But the problem is that we have this guy again, Menem, that's still boring. And he says that the unauthorized modification of ABAP programs directly in production system is possible. So let's see why. Each of these systems, each SAP system is running with its own database. So you can have Oracle, SQL Server, Informix, DB2. These attacks are not Oracle related. They can be in any database that it's running with. So you as an attacker might find a way to modify an ABAP program directly in production, but it's not trivial. So what an attacker will probably do is to go and attack directly the SAP's heart, that is the database. So he can exploit this SAP plus Oracle authentication weakness. He can use of one of the default user credentials for the database access. He can run a database exploit and take over the database. And remember, this is important, that even though he doesn't have, you may be thinking like, oh, no one on my network can get direct access to the database because it's firewalled. As I told you before, if the attacker got access to SAP system and his SAPOL, he can go down into the database. So it's pretty much the same. One of the issues is that there is no CRC or signature on the stored ABAP code. So actually, there is nothing that prevents the attacker from modifying the code at the database layer. Okay, so I think this is the second demo. So let's go into simulate something. I'm going to show you how an end user from your accounting department, for example, is creating a new vendor. Okay, so this guy Sean is going to log in into SAP system. This is like a big Wall Street company. So he goes to the FK01 transaction. This transaction is for creating vendors. So he will create vendor 8888, whatever. Here's the company code, well, just technical information. And he's going to say, okay, this is vendor, yes, no, let's choose a different name. I don't know, Missiles Inc. I think I spelled it wrong, but yeah, I don't know. So, well, we have to complete some fields, and this is a US company. So, well, he can fill in tax information, physical address, all of the information that we can skip for the demo. But what we want to stress is that he is going to configure this vendor's bank account. Okay, so the Missiles Inc. told him that his account number was 9090909090. And the account holder is John Smith. Okay, so this guy, Sean, creates a new vendor, configures the bank account, and saves the record. Okay, it's going to take a second because usually SAP systems are not run on laptops. So be mercy with mine. I think it's saved. Oh, sorry. No, this is too long. Okay, less 90s. But remember that there is a 90 there. Okay, so it's created. So now if we go to display that vendor information in another transaction, and we show the payment information, this vendor is configured with that bank account. Okay? So John finishes his work, and he goes home, he closes, and he goes home. So now this attacker will come in, and he's going to execute a Python script. Backdoor, was it? Yeah. So then I'm going to show you what it's doing. But it's going to be attacking this system. Sorry. And this payload, I think it is. Yeah. Okay, so the backdoor is doing something remotely to the SAP system. Okay, that's it. It says that backdoor is installed here. So John comes the next day, more relaxed, and he logs in again into the SAP system. Oh, sorry. Before that, there is something else that the attacker has to do, that is to reset user buffers. That is, well, something technical, but as the attacker has some controls, he has to do this synchronize, and that will invalidate all the current information stored in the buffers. Okay, so then the attacker finishes his job. So then Sean comes in. Let me log in again, just in case. Okay, so John comes in. Now it's going to take a bit longer because he doesn't have any kind of information in the user buffer. So the SAP system is pretty much recompiling a lot of programs that were already precompiled for this user. So it's going to take a little bit to recompile all that information. Okay, let me try to see if I can. Okay, so Sean needs to create a new vendor. Here you can see that it's compiling it's compiling that ABAP program, SAP MF02K, that is a program that is handling the vendor creation. Okay? And it's recompiling it because the attacker modified it in the database. And he invalidated all the buffers. So this is also going to take a little bit. It's taken more than a little bit. Okay, there it is. So now he's going to create a new vendor. Okay, he's going to create vendor 434343, whatever. The same company code, the same account group. So again, the SAP system is going to need to some recompiling. So now he's creating the names, world company XYZ. Okay, so he creates a new vendor in the system. Again, it's American. And he will say that, he's again configuring, this bank account for the vendor. So he uses, this vendor is using bank account number 55555. And he's Michael Johnson, whatever. So he saves the vendor information. See that there is a lot of fives here in his bank account. It's pretty much what everything Purshon does every day. So now he goes to see this vendor information. Yes, work company. And hopefully you see that there is a different bank account. Okay. So actually, I don't know if you get the point, but the backdoor has modified, without any kind of issue, problems, the vendor bank account to Menem's bank account. So every automatic payment that the SAP system is doing to that vendor, that money will actually go to the attacker's bank account. Okay, so he's like stealing money from the company. Okay, so that's the second attack. Okay, and finally, the last attack is how the attacker can backdoor the authentication procedure. So that is that SAP tries to protect certain critical ABAP programs. Okay? So if you, I'm going to show you now. So that is that if you want to access some of these programs, the system will tell you that you cannot access the source code because it's protected. So I was like kind of trying to figure out how this was implemented in the system. The first thing that I saw was this report table where the source code is stored, contained a field, SQLX, that was described as source code protection. So I removed the X for many reports, but I couldn't still access them. So then I realized, I also found it online later on, that there was a special ABAP magic string. That's that one. So if you develop your ABAP program and you include that line at the very first line, you will prevent anyone from looking at that source code. Yes? Yeah, this is what I just said. But there seems to be something else going on critical ABAP program protection. So let's talk about SAP MSysT. That is probably the most critical piece of ABAP code in an SAP system, because it handles the user authentication procedure. Okay, so this screen, sorry, let's close this one. This screen here, if you see in the right bottom, this is actually an ABAP program, okay, that is processing your client user and password. And it's SAP MSysT, okay, so it handles the user authentication. what I discovered was that this program was protected through a specific hard-coded check in the kernel. So if you get the kernel binary and you analyze it, you'll see that there is a particular piece of code that says that if the requested program is SAP MSysT or some others, don't access it. It has nothing to do with the magic ABAP string. But what I realized is that the check was only performed on ABAP, on the ABAP program name. So you can pivot it and change the name in the database, get the source code, modify it, and write it back. So it's possible to bypass this check, and we're going to see that. Okay, I'm just going to show you, first of all, that if you try to access this program source code, so here it's a transaction to display, this is the ABAP editor. If I try to display this, at the bottom says the source code is protected, see explanation for long text. Let's see what the explanation gives. That usually is the same text. It says that the desired source text is protected by SAP because changing it will cause system errors. Okay, so you cannot access it to display it, and you can be pretty sure that you can, you can less change it. So let's see what the attacker can do with this. I'm going to execute another payload of the backdoor installer, payload number 2. So it's connecting to the database. He's going to be using the remote HTTP credentials payload, injecting payload, modifying the SAP MSysT and other DIM pros in the database, invalidating currently created ABAP loads, and the backdoor is supposed to be installed. So in this case, what the attacker still needs to do, this is kind of a noisy attack, but I think it can be pretty much improved, but by someone more skilled and with more time than me, is to, he has actually to restart the system. Okay, so he can just put a background show to reset the system at some time. There are also some procedures in the system administrator tasks that reset the system for time to time. So he'll need to reset the server. So to do this, he will execute a special program that's called RSBD COS 0. That is actually here. Okay, RSBD COS 0. Actually, well, he can do pretty much what he wants here because this is like a command shell through the SAP system. Oh, this is not the dir, sorry. I'm in a Linux system. So he can execute operating system commands. And what he'll do is to run this command, stop SAP R3 and start SAP R3. Let me check. Okay. So he will run this command to stop the SAP system and restart it again. So this will take a little bit, but at some point the attacker will lose connection because the system is going down. So while this is going on, I'm going to show you what this is backdoor installer script. Backdoor installer. So this is basically a proof of concept that I developed. It's actually connecting to the database with credentials. Okay, but remember, this is not only the attack vector. The attack can come from any of the other components. And let's show this payload, the one that we are executing right now. This will be like the ABAP payload that we are injecting into the database, overwriting the original ABAP payload. So this will be like compressed ABAP source code. And it's just simple SQL queries. Okay, so we are updating the value of program SAP MSysT to this data, to this payload. So we just change the code of the program in the database. We change some more DIM pros, we delete the ABAP loads, and we just commit. Okay, so that's only what the attack does. Okay, this is still not resetting. Let's see. Okay, this may take a while. I can take the chance to ask. Okay, let me see. Maybe not. Okay. I can take the chance to ask, to try to answer one question if you have one. No question. Okay. Yeah, the question was if the first payload, the bank account payload, changed it every vendor's bank account or just the first one. It actually changes every vendor bank account. And it's a good question because it pointed me out something that I just showed you that the backdoor was modifying the vendor bank account, and it was actually showing you the new bank account. But the backdoor could still show you the legitimate bank account and still internally use the attacker's bank account. So it's really difficult to detect. Okay, that's a good question. Let me check if I have it running. Okay, no, I can get, yeah, well, anyway. Yeah, the question was if in the first example that I changed the old hash value, it was possible to detect that in the system log. What you would be able to detect that in the system log, if you're doing it through the SAP system, as I did, like entering the SE16 transaction, accessing the database table, entering to debug mode, you may get some information in the system log. If you do that directly through the database, you get no information at all. Okay, so the system was rebooted, and it is supposed that this logon screen is now backdoor. So what we're going to try to do now is to, let me see, log, Apache, training, access. Okay, so this window here will be the attacker's system in China. Or in Argentina, not to have no hard feelings with China. So now the legitimate users will try to log into the system using his password. And it's the, okay, so here the attacker system got a special HTTP request, and here is the client. Well, the client is in a bad format, but it's a minor bug. You have the username and the password that the user used to log in. Okay, so if anyone logs in again, I'm making a mess here. Anyone, John, with the wrong password or whatever, just to show you, you'll get John passwords. Okay, so this basically means that an attacker could be receiving any SAP user's credentials from the time he wants to. Okay. That's 3 demos running without problems. Something's going to happen today. Probably the ceiling is going to fall. So, which is the protection against this? It's actually not possible to protect against this from the SAP layer. We're going to get into that in, I think, next slide. Yes, so in order to protect against this and to help customers try to detect this kind of threat, we developed the Onapsis Integrity Analyzer for SAP. So basically, what we're trying to do with this tool is to try to help to detect and prevent fraud, okay, like this one. So this could happen in Vegas, so watch out with what you're doing tonight. This tool will try to detect modifications in ABAP codes. You can download it, well, not yet, it's upcoming. I hope to have it running for next week as well. And it's only working, so far it's a proof of concept, it's only working for SAP with Oracle 10G implementations. It was developed by one of our guys, Jordan Santarcieri, and I kind of gave him some guidance on the tool, but the actual code was pretty much developed by him, so he gets the kudos for that. Why do you need this kind of tool? I mean, this or any kind of this approach? Because you cannot detect the backdoor from inside the SAP system itself. This is just a basic concept. If your Windows system is backdoor, you cannot use that system to check if it's backdoor. So you cannot use the SAP system. What not very security aware auditor will try to do is to check programs' last modified date. I've seen this in auditing reports, a big 4 auditing reports. The backdoor can leave, why? Because when you modify a program from the SAP system itself, it updates the last modified dates. Of course, if you're just accessing through a database, you can leave that field untouched, as we just did. And also, the program, the EVA program that you're running to check if this system is backdoor can also have been backdoor to hide the backdoor. Okay, so it's like recursive. So you cannot trust, you cannot rely into that. You may try to do this manually, but you should know that there are hundreds of thousands SAP programs in a regular SAP installation, so this may get a bit difficult. And what the program does is really not technical, it's not rocket science at all. It connects to the database and performs a snapshot of sensitive, or actually of all EVA programs. So it's getting a hash of each EVA program code and downloaded it to a local database. So then you can periodically make new snapshots and compare them if there is any kind of unauthorized modification. This is far from being perfect because it has some weaknesses or drawbacks, like you have to do this, for example, the first day you install the SAP system, because if you do it now, you don't know if it had been backdoor before. But what you are planning to do is to release some signatures for baseline installation so you can compare against that, but it's going to take a while. And it's also important to track SAP nodes installation because they can modify EVA programs and they are not backdoor. So it's difficult to manage. The idea is that it will help you to detect some suspicious modifications, and you should do further investigation into that. So I'm going to show you how the tool looks like. No, this one. Okay. So just to make it faster, I have already taken a snapshot of one of the systems before we backdoored the business module. And now I'm going to take a new snapshot. So I had to connect to the database. You specify the Oracle instance ID, the user you want to use to connect. You can, if you don't use custom scan, it will make a signature of all the existing EVA programs in the database. Okay, so it's going to take too long. What you're going to do is use a custom scan to scan only for and to snapshot only some small subsets. So I load this file, and you have to specify where do you want to put the output. So this will be the snapshot post backdoor demo db. So you save it. You can check connection to see if everything's working. Everything seems fine. You can proceed with your snapshots. So you run this, and it will connect to the database, get a SHA-1, I think was a hash, and save it to your local machine. So what you should do from time to time is to compare snapshots. So you go here, and you load the snapshot that you did before. So I have the one before the backdoor somewhere pre-backdoor. And now I'm going to load the post-backdoor demo file. So I hit compare, and we'll see that the business module that we modify on the database was detected to have different signatures. Okay, so then you have to make your investigations around what happened with that program. Okay, So it can tell you if there are difference in compiled programs, there are missing programs, there is any subnode related to this program, so you can try to think that maybe it was a subnode. But the idea is that you can do this with the tool. Oh, like that. Okay. So, summing up. Also, when I did this presentation, there was like some kind of concern that, or misconsiderations that this was an SAP vulnerability. This is actually not an SAP vulnerability. I mean, the backdoor threat affects every information system, so it's not SAP related specifically. What we have just shown is that it also affects SAP systems. And also it's important to realize that once an attacker has full control of a system, it's really, really difficult to restrict his activities. Okay? So SAP is not the exception in this sense. It will be the same as saying that Microsoft, because is flown, Windows is flown because once you are administrator, you can create a new administrator. Okay? So that's not how it is. I hope that you have got a clear idea that it's possible to directly modify AVA programs in production without going through the transport mechanism. As you have seen, backdoors can have really devastating impacts over business. I mean, you can make, an attacker can make sabotage attacks just to mix the information. He can do fraud attacks to change bank accounts and detour money. Don't forget that the direct database access is not the only attack vector. The attack can come from several places and exploit these trust relationships. Someone doing this, it's really not about having fun with your SAP system. It's probably something else. You can try out Intelligent Analyzer and give us your feedback. It's just free tool, so probably they have some improvements to be made on it. Thinking about protection, I think that the best cost-effective protection is to minimize the probability of the initial compromise. Okay? Once you are compromised, it's really difficult to try to keep running secure. So the best choice is to try to block the first attempt. So you should implement some automated controls and do periodical vulnerability assessment, pen test, security audits of your entire SAP platform. This is also important. Something important I want to stress is that usually when you get an audit of your company's SAP system, auditors just look at the production system and maybe the production client. We have found most of the time that it's possible to attack the development system that is usually less with weaker security settings, and then jump to the production system. So you should analyze every SAP system in your network, not just production. And yeah, I think that's the only systematic choice. There has been some controversy about this talk, but I think that it's something that we should analyze objectively and responsibly. So just showing that this is possible and someone could be actively exploiting this. So we have to deal with that. So we have 10 minutes for questions. Okay, the question was, if you have your SAP system updated to every single security node that is available, are you still in danger of a SAP backdoor? I have to say that yes. Not because, I mean, you definitely reduce the attack surface, but there are human errors like you have to be really, it's not, security nodes, for example, doesn't affect or are not related with segregation of duties issues. So if you have a user who can do more things that he should do, he can install the backdoor. If he can exploit the operating system, unpatched Windows box, he can get to the database. He may be able to exploit the database. So it's like you have to cover all the weak links. Yeah. Anyway, you should do that. You should install every SAP node, but it's not a foolproof concept. Yeah. Sorry? The tool, the backdoor installer? Yeah.
The code is already compiled.
Yeah. No, it's not compiled, it's compressed.
It's compressed.
Yeah. No, I didn't reverse the compression algorithm. I just created the ABAP program in an SAP system and yeah, put it in the site. The question is that I say that it's possible to jump from dev to production system. How it's possible to do that? SAP systems are full of interfaces between each other. There are special kind of interfaces that is called RFC interface. RFC is a proprietary SAP protocol. So because of different kind of interaction between the system, you may have this kind of interface. And it's quite, unfortunately, it's quite easy that you just like go into a special transaction and with the mouse, you just log in into a remote system. But I mean, that's an administration issue most of the times, not like a SAP vulnerability. But it's really common to find it. Yep. You may not get a direct link from dev to production, but dev to QSA, QSA to pre-production, pre-production to production. Yep. Any further questions? Yeah, sorry. Sorry, I cannot hear. For web app? But the question is, if I understood it right, if anyone, if there's any proof or public information about anyone exploiting ABAP vulnerabilities. Well, actually, this is like not an ABAP vulnerability itself, but if I get your point right, ABAP programs are susceptible to have security flaws like SAP applications, PHP applications, you have remote file inclusion, SQL injection, and that stuff. SAP ABAP programs also can suffer from that threat. So yes, you should do a code review and use automated tools probably to look at ABAP code. The thing is that this is not, I don't regard this as a vulnerability. I mean, what we are doing is modifying something in the database, and the system has no way to know that it was modified. Or why? Maybe they could deploy something, but they don't have. So I don't regard this as a vulnerability. It's more like an exploitation technique or a set of steps, but it's not a specific vulnerability. So anyway, if I got reports of someone backdooring the SAP system, yes, not with this level of complexity maybe. It was probably some more malicious developers that created malicious ABAP programs. So if the program received a parameter, obscure parameter with his name, his daughter's name, it will delete all the files, like a logic bomb or something. But not with this level of complexity. Any further questions? Yeah. If there's any reason I cannot make a standard list of hashes of ABAP programs. Why SAP is not providing us the firms? You probably can send them an email. Yeah, that will be actually the best choice. And probably this kind of thing drives that. The best choice that SAP, I kind of talk with them, and probably they're looking into it to some point. But if SAP provides us with the default signatures of each ABAP program, it will be really easy to detect backdoors, and that's what would be the best of it. Yeah, that's it. Sorry? Yeah. Yeah, but the thing is that he's saying that you can also update the hash, but I mean, we know that everything is like breakable, but that will prompt you to reverse the signature algorithm procedure. And also, if SAP deploys some kind of PKI infrastructure that they digitally sign it with asymmetric and digital signatures, it can be much more difficult to bypass that. So there are ways that they could improve this, at least to make it more difficult. Any other questions? Yeah. Okay. Yeah, the question is that if we are providing integrity analyzer as an open source project, or it's just a small proof of concept, and then we're going to build something commercial about it. The question, I mean, so far we were planning to release it like not open source. Bizploit is open source, so you can get all the code of Bizploit and this ERP pen testing framework. But actually, we still don't know what honestly, we still don't know what we're going to do with integrity analyzer. But yes, probably still the only solution that's going to be open source is Bizploit. At least at this point, we have to look at it really honestly. Any other questions? Well, anyway, you have my email address. Are probably not going to be so much online these days, but probably when I recover next week, I will be available. So you can just drop me an email. And so thank you.